on my channel. In this video, I'll be going through this worksheet from Punggol Green Primary School, Primary 4 worksheet on cycles and matter. Now, I was teaching in this school for a few years. I was a HOD science there. And here I'll be going through the answers and how to tackle cycles question. Let's get started. Now, study the classification table below. Now, this is a table, and every table there are headings. The headings here are not given to you, but I can see here these are all liquids, these are all solids, these are all gases. So basically, those are the different states of matter being classified separately in gas, solids, and liquid. So in which group should orange and pencil case be classified? Orange juice is liquid, that should go under C. So orange juice should be C, okay? And that's the answer. Just double check. A pencil case should be a solid, so pencil case should go under B. And that's true. Answer is 4. Next one. Study the flow chart carefully. Now, a flow diagram requires you to follow the direction of the arrow, okay? Now, and we look at the start, where it starts from. It goes down here. Does it have a definite shape? So let's do a quick recall of your understanding of your solid, liquid, and gases. Now, there are different characteristics of solid, liquid, and gases that you must be aware of. Your teachers would have been revising with you very often. So, for example, solid would have, you can describe them as, for example, their volume. Does it have a fixed volume? Does solid have a fixed shape? Can it be compressed? These are kind of the common questions people ask to try to identify whether something is solid, liquid, or gas. Right? So you know for sure solid has a fixed volume and fixed shape. For example, and cannot be compressed. So I will put a tick here. Eraser, for example, right? If I come back tomorrow, the eraser will still be the same shape and will still occupy the same amount of space. So the same volume, right? Fixed volume means same amount of space. So it's a solid. For liquid, well, the amount of space it occupies is the same, so fixed volume. But the shape of the liquid is not fixed. It's dependent on the shape of the container. So, and liquid cannot be compressed. For gases is the only one that can be compressed. It has no fixed shape and no fixed volume. But it can compress gas, and gases will occupy the shape of the container. So this is a basic quick revision of your 3 states of matter and certain properties or characteristics. So does it have a definite shape? Yes, and that tells you that definite shape, right? That tells you A must be a solid. So A must be a solid. So I have solid, solid, solid. Now next one. Does it have a definite shape? No. That means B and C both have no definite shape. They're all on this side of the flow chart here. Does it have a definite volume? Yes. So something with no definite shape but has definite volume, C must be a liquid. So C must be a liquid. Okay, and that's the answer. It's 2. Now, shadow is a non-matter, bowl is a solid. That's a triple check. So B therefore has no definite shape, no definite volume. B must be a gas. So air is a mixture of gases. So answer is number 2. Next. Now when Mary added some ice cubes to a glass filled with water, the water overflows. This tells us something. Now the idea is this. When something overflows, it means that the space inside was occupied. So the ice here must have occupied some space that were previously occupied by the water. Right? Like this eraser is occupying this space now. To make the eraser move away, I must now occupy the space previously occupied by the eraser and replace it with something else. Okay, this tells us that therefore water, the ice cube occupies space. The ice cube was occupying the space previously occupied by the liquid. Okay? It's nothing to do with mass or weights. If you got to do with mass or weight, then there might be some weighing scale present. Right? Words like weight is about force, lighter is about force. Alright, there's no compressing of water here, otherwise I'll be using it as syringe. This shows you two containers of different shape. If the containers are of different shape, therefore when water goes in, the volume remains the same but the shape changed. Remember our quick revision just now? Liquid has a fixed volume, alright, but the shape is not fixed. So here, what will change? Only the shape will change. Answer is 3. Next one is part of this. Sometimes some question asks will require you to use the same diagram for 2 questions. So what characteristic of method does the experiment in question 4 show? It shows you that liquid has an indefinite shape. Indefinite is another word for saying not fixed. It has no fixed shape. Next one, question 6. Now, Jaden listed some examples of matter and non-matter. Non-matter are things that, now of course you know matter has certain characteristic. Matter definitely will occupy space and it has mass. Now music is a non-matter. It doesn't occupy space nor does it have mass. Heat is a form of energy. Light is a form of energy. These 3 things here do not have mass. They do not occupy space. So I wrote wrongly, this part should be matter. So here, by looking at non-matter, I know for sure already answer is number 3. Answer here, non-matter, sorry, I said something wrongly. Non-matter, these are all non-matter. Heat, light and music. I know for sure air is wrong. Air is matter, it's a mixture of gases. Now, let's look at matter here. Fire is actually energy, heat energy. So this is not matter. Okay, so 1 is out. Steam is gas. Gas is matter. This is correct. Lightning is a form of energy, electrical energy. It is non-matter. This is wrong. So answer is 2. Okay. Next one now. The diagram shows a pump containing air. Alright, and this kind of question always tells you about, they try to put more gases into a container that has less volume. And very often students they're not tricked, but they don't remember that air can be compressed, that you can have more air that can enter a smaller container. The shows a pump containing 300 cubic centimeters of air. So here, this part here is 300 cubic centimeter. The air is then pumped into a container, a larger one, with 100 cubic centimeter of water. So the amount of space left here is 400 cubic centimeter. Right, 500 minus 100 is 400. So what is the volume of air in the glass container when the piston is pushed all the way in? Now 300 cubic centimeter of air will go in. But remember, gases have no fixed shape and no fixed volume. The gas will just fill up the entire container. The small volume of air here, the smaller volume of air, will just fill up this part. It will just fill up. It will just spread out, okay? And occupy the space there. So therefore the new volume of air in the glass container will be 400. Right, will be 400. Okay? Now next one. They are placed on a beam balance. I can see since they are balanced, right? So the weight of both balloon A plus the air inside and balloon B plus the air inside are equal. Therefore, they are balanced. Now, what happens when when balloon A is removed? Remember, you must always have a green pen ready when you're doing correction. If you have not, please do so. When A is removed, now there is which side now here will have more mass? B, right? Therefore, it will now tilt this way. From this, it will tilt down to this. So the way you write your answer must show clearly you know that balloon B will tilt downwards, or tilt towards the right. So for example, here, there are many ways you can say it. The pen with balloon B will tilt downwards. The pen with balloon B will move downwards. The pen with balloon B will go downwards. No matter how you describe it, you must tell me you understand this pen will go down. Alright, that's what happens when A is removed. Next one, based on what you know about the characteristic of matter, matter occupies space, matter has mass. Okay, these are the two characteristics of matter. What do you think is the aim of the experiment? Well, if both of these has mass, alright, then of course they will both have the same amount of mass, they will remain balanced. By removing this, then you can see that well, air has mass, balloon has mass. It proves that air has mass. And that's the aim of the experiment, that matter has mass, air has mass. A better experiment actually will be if I left the balloon here and I just left the air, just poke a hole, just let the air out. So I'm left with a balloon without air, a deflated balloon. Then both sides will have balloons, but only this has balloon plus air, this is just balloon. This will be an even better experiment for this answer. Next one. Jasmine lowers 2 containers into a basin of water. The bottoms of the container are cut out. Container A has its cap on, while container B has its cap removed. Draw a line. So here there are instructions given. Some of you forgot to do it. Draw a line to show the water level. Remember, air can be compressed, right? If air can be compressed, when the container goes down here, alright, the air inside here can be compressed a bit. So some water can go in a little bit. So you should draw some water inside. Not completely no water. Some water can go in because air can be compressed. So this is the first line. Next one here. B, when water goes in, it will occupy the space previously occupied by the air. What happens to the air? It will be pushed out by the water that goes in. Okay, the water that goes in will occupy the space occupied previously by the escaping air. So explain your answer for the water level in bottle A. So explain for this. Well, this is how you explain it. The water level in bottle A will be lower than water level in B. See, water level in A is lower than in the basin. Why? Because there is a stopper above. And what does the stopper do? It causes the air, stopper, or you can say the word cap, causing the air in the balloon to be trapped. Hence, only a little bit of water could enter. Why? As air can be compressed. So if the question asks you about water level, you must talk about water level. And since the water level is different, your answer must highlight the differences in the water level. How do you describe the difference? One is higher, one is lower than the other. Okay, one is lower and the other one is higher. Next one. Explain your answer for the water level in B. So what is the water level now? Notice water level inside and outside. How do you describe the water level? Very good. They are the same water level. Alright. So you see, the water level is exactly the same. But this is just mentioning the evidence from the question. It doesn't explain it yet. To explain it, you need to talk about, okay, so what else you observe? There's no cap here. There's no cap in bottle B. So what if there's no cap in bottle B? The air in bottle B can escape. Right? Then water is able to enter and occupy the space previously occupied by the air. So that's how you answer the second part here. Coming to the end, hanging there, okay? The beaker contains 150 cubic centimeter of water. Object B was placed inside. You can see it's a solid, right? And there's a new water level. Remember, solid has mass, occupies space, and since it occupies some space here, if this was the previous water level, therefore this difference here now, this volume of the water here must be the volume of that this solid has occupied. So because this solid occupied this space here, alright, so the water level has to go up. Because this solid has displaced the water that was previously occupying the space here. So how to find the volume of the solid? Just subtract these two to get the answer. Alright, and you must state the units. No units, you will lose marks because it can be 18 kg, 18 cucumber, 18 monkeys, not 18 whatever, right? You must tell us the units. Explain why the water level rose and object B was placed inside. Remember the part about it occupying space and displacing the water. So object B is a matter or a solid and it occupies space. Since both object B and water are matter, and two matter cannot occupy the same space at the same time. This highlighter occupies this space here. My pen also wants to occupy the space, but I cannot. It must move away before it can occupy the space. Can the pen occupy the space? Yes, but not at the same time as the highlighter. Alright? They cannot occupy the same space at the same time. So since both object B and water are matter, when B is lowered into the beaker of water, the water level rose as B took up some of the space. Right? Because no two matter can occupy the same space at the same time. Last question. Raj set up an experiment as shown below. He blew through the straw and bubbles were seen. So he blew through the straw here, bubbles were seen. Okay? So the air is the purple colored part here that I blew in. So explain why the water level in the inverted beaker decreased. So at first the water level was here. But as the bubbles went in, the water level went down. Why? Because air is matter, right? Matter, if air goes in, what happens to the air? It will occupy the space inside the beaker. But water is really there. So what will the air do? It will now take over the space that was occupied by the water previously. And where will the water go? It must go elsewhere, it must go out. Therefore, the water level outside will rise. Whereas this one, inside, water level inside will decrease. So why will the water level in the beaker decrease? Because air is matter and matter occupies space. So, but this is not enough as an answer. This is what I call a motherhood statement. You must always explain further. Since both air and water are matter and they cannot occupy the same space at the same time, when air is blown into the beaker of water, water level rose as air took up some of its space. Okay? The water level, and air is blown into the beaker of water, the water level, in the beaker decreased, not rose, okay? Decreased as air took up some of its space. Lastly, what does this experiment tell us about the property of air? Basically, air is matter and air occupies space. This is the property of matter. Now, can I write water level rose here? Can, but I must say water level in the basin. Because there are two water levels here. There's water level outside and water level inside. Okay? Here you're asked to explain why the water level in the inverted beaker, which is the one inside the beaker, why did it decrease? So here I think I could have been clearer in my answer. I should say water level in the beaker decreased as it took up some of its space, as air took up some of its space. And this concludes the explanation and the revision for matter, states of matter, and how matter occupies space, matter has mass. All the best to your revision. I'll see you in the next video.